Hello everyone, I'm Sumalata. In today's class, we are going to start new chapter, that is group 17 elements. Okay, I'm trying to give more information within less time. So try to utilize this chance to learn um, information about this chapter and try to apply while doing your objective bits. Okay, because I'm giving you all these points from your NCERT and academy textbooks. So please watch and share these videos to your known people. Mention your words in comment box. How do you feel about these lectures? And also subscribe, like also. Okay, then we will start our class. Group 17 elements. Group 17 elements are also known as 7th A group elements. All elements present in this group are known as halogens. That's what we can also call them as halogen family. So we can see which elements are present in this halogen family are group 17 elements. Halogen family, is it visible? No, not visible. I will write it again. Okay, yes. Halogen family, yes. Halogen family are group 17 or 7th A group elements. These are especially fluorine, chlorine, bromine, iodine. Fluorine, chlorine, bromine, iodine, astatine, astatine. These 5 elements are present in the group 17. Okay, this astatine is the radioactive element. I am indicated with the star. Just remember, okay, radioactive element. If you see abundance of these group 17 elements, especially fluorine available in the form of insoluble salts. Insoluble salts. You can see few examples. CaF2, this is the fluorspar. CaF2 is the fluorspar, and Ca3PO4 taken twice. CaF2, this is the fluorapatite. This is the fluorapatite. 3Ca3 you can add. Okay, fluorapatite, and also cryolite. If you see Na3AlF6, Na3AlF6. These are the insoluble salts of fluorine containing materials. Insoluble salts of fluorine containing materials. And also if you see our surroundings, which matter or which material going to be have fluorine is one of its constituent. If you see soil, in soil, and mineral water plants, and another one is teeth of animals, next to bones, all these are also having fluorine as one of the constituent in that matter. Okay, and coming to chlorine, bromine, iodine. Chlorine, bromine, iodine, if you see, these are present in their salt form, especially in sea water. If you see salt forms, in the form of especially those salts are sodium salts of chlorine, bromine, iodine. Next magnesium salts of fluorine, chlorine, bromine, iodine, and also potassium salts and calcium salts. If you take sodium salts, you can see NaCl, NaBr, NaI, like that, NaF. Okay, if you see magnesium, MgCl2, MgBr2, MgI2, like that, KCl, KBr, Ki, okay, CaCl2, CaBr2, next CaI2. Okay, these are the salt forms present in the sea water. Especially if you see sea water, 2.5% by mass, 2.5% by mass, 2.5% by mass, NaCl present in the sea water. 2.5% by mass, NaCl present in the sea water. If you see and also this NaCl, nothing but chlorine, especially present in dried up sea. decay. If seawater, dried up seawater, if you see, dried up seawater forms one after another layer. So all that water going to be dried and it will form a decay. So in that decay, especially chlorine, we are going to found. So chlorine in the form of NaCl, and another form is carnallite, KCl, MgCl2, 6H2O. KCl, MgCl2, 6H2O is the carnallite. Okay, especially mainly these two forms are the dried up sea level we can able to find out. And then another, if you go to marine water, marine life, there 0.5 percentage of iodine present in the form of sodium nitrate, and 0.2 percentage of iodine present in the form of sodium iodide. Okay, then this is about occurrence and availability of all these elements. Astatine is the radioactive element, so that its half-life is very less, so no need to discuss about it here. Okay, then coming to general properties, if you see, especially first one, first one is electronic configuration. You can see electronic configuration, okay, you can complete the remaining word. Electronic configuration, if you see, general electronic, outer electronic configuration for these elements is NS2 NP5, NS2 NP5. So for individual atoms, you can see, for that one you need to know about atomic numbers. Okay, fluorine is the 9, so its outer shell electronic configuration is 2s2 2p5. Fluorine, next chlorine, if you see, chlorine 17 3s2 3p5. Fluorine, next bromine is the 35. Okay, its outer shell electronic configuration is 4s2 4p5 and 3d10. Okay, next bromine, iodine, you can fluorine, bromine, iodine, if you see, it is 53. Its electronic configuration is 5s2 5p5 4d10. Okay, 4d10. Astatine, you can see, is it visible? Astatine, yes, visible only. Its atomic number is 85. 6s2 6p5. Next 5d 10 4f14. This is only about outer shell electronic configuration. For full electronic configuration, you need to add before this one nearest noble gas. For fluorine, helium, next chlorine, argon, next krypton, xenon, radon, like that. Okay, this is about outer shell electronic configuration. By seeing this outer shell electronic configuration, what have you decided here? Only one electron less to get octet configuration, so that these are highly reactive. Because of less one electron, they always try to get that one electron and become noble gas configuration, so that these are highly reactive when compared to the other elements present in their respective periods. Okay, this is about electronic configuration. Second one, you can see, second one is atomic radius. If you see, atomic, ionic and covalent. Okay, these three I want to tell you together only. Covalent radius, atomic, ionic and covalent radius. Atomic, ionic and covalent radius increases down the group. You should write. While telling, you just listen and write it, because it is tough to write each and every sentence on board, because it is very less space, so that you need to understand. Okay, so atomic, ionic, covalent radius increases. Upward arrow here I am indicating, that is increases down the group. Here see, fluorine, chlorine, bromine, iodine, astatine. From fluorine to astatine, atomic, ionic and covalent radius will going to be increased. Then you can see ionization enthalpy. Ionization enthalpy. Okay, this will decreases down the group. Ionization enthalpy decreases down the group because size increases, so force of attractions towards the outer shell will going to be decreased. That is the reason removing of electron from outer shell is going to be very easily. Okay, so this is the ionization enthalpy decreases down the group. If you see next properties, I'm going to rub this one. Okay, you can take screenshot, or if you want you can write. Just 1 second you can hold it and then you can write all these things. Yes, my dears, next one is electron gain enthalpy. I don't want to rub this because it is useful to apply all these properties. So electron gain enthalpy. Electron gain enthalpy, if you see, electron gain enthalpy not follow the same trend when you are if you observe remaining groups. Here it is little bit different, because if you see from fluorine to chlorine it will increases. Fluorine to chlorine increases, chlorine to iodine it will decreases. Fluorine to chlorine increases, chlorine to iodine decreases. Astatine no need to mention because we already know about it is the radioactive element. So fluorine to chlorine increases. Generally electron gain enthalpy for the first atom it will be more. But here why fluorine less electron gain enthalpy? The reason behind this one is more repulsions takes place between electrons present in the p orbital, 2p orbital of a fluorine atom. That is the reason electron gain enthalpy less for fluorine and more for chlorine, and then remaining will be decreases. Okay, this is about electron gain enthalpy. Then you can go for electronegativity. Electronegativity, if you see, electronegativity decreases down the group. Okay, electronegativity decreases down the group. Decreases. If you see from fluorine to chlorine, bromine, iodine, astatine, electronegativity decreases down the group. Why? Because that means the size increases, so that the electron taking capacity will also be decreases. But here you need to remember one point: fluorine is the most electronegative atom when compared to the other elements present in the group and also in the periodic table also. Fluorine is the most electronegative atom present in the periodic table. I mean, if you compare to other elements, fluorine is the most electronegative atom. Then coming to next one, electronegativity after density. Density and boiling point, and then melting point. Boiling point, melting point, if you see, all these three increases because these are all interlinking with each other. So density increases. Okay, density increases, boiling point also increases, melting point also increases, my dears. Okay, just remember. Okay, then we will move to next property is what? Bond energy and bond distance, bond dissociation enthalpy and bond distance. First you can say about bond distance. If you see bond distance, next property is bond distance. Bond distance. Before that bond distance, you need to remember one thing: all halogens are exist in a diatomic state because these are all one electron less to the octet configuration, so that they are sharing with each other, they can form molecular state, that is a diatomic state. Okay, so here bond distance, so halogens indicate with X, so in the form of X2. So the bond present between X and X increases down the group, increases down the group, my dears. Okay, next one, bond dissociation enthalpy. Bond dissociation enthalpy, if you see, bond dissociation enthalpy will be also in yes, not increases, decreases down the group, because bond length increases, so decreases down the group because bond length increases, so that we can able to easily break out. Now once you observe here, this is the marker. If you want to, just imagine it is a stick. If you want to break it up into two pieces, so you can easily, and that means here this is the marker, so little bit tough. So imagine this is a stick, this size of stick, you can easily break out it. But imagine this much of stick, is it easy to break out into two pieces? No, it's not impossible. I mean, it is possible while taking knife or any other thing, or you need to use so much of energy. So that here also, while going down the group, bond distance increases, so that bond energy will be decreases. So you need to apply little energy. Okay. Then coming to next one, it's physical state. Physical state, if you see, fluorine and chlorine, fluorine and chlorine are the gases. Fluorine and chlorine gases. Okay, bromine is a liquid. Okay, bromine is the liquid. And if you see colors, fluorine is in which color? Yellow color, yellow. Okay, chlorine is greenish yellow, next if you see bromine is the red color, and fluorine, bromine, iodine, if you see, iodine is a solid, and which is having violet color. Okay, remember violet color. Why these are having exhibiting color property? Because the last electron, gained electron is there, that electron going to be transformed from one energy level to another energy level. At that time, energy is going to be absorbed in the visible region, so that while excitation, de-excitation, some energy taking and some energy released, at that time they will going to be show color property in the visible region. Okay, these are all about physical properties and physical trends of halogen family. I hope you are all understand about this one. I think I gave you information in easy way. I hope you are all get this one. If you feel useful and informative, please do subscribe, share these videos to your known people, mention your words in comment box. How do you feel about my lectures? And don't forget to like it also, okay? Because your like, subscription, your comment will makes me more energetic to give more and more knowledge to you. So try to learn with me. I'm trying to give you more information to you. Okay, bye students, we will meet in the next class.